We are planning to test out how you would defend Earth from an incoming asteroid. For the first time, helping humanity save itself from a threat of a killer asteroid.
An impact on Earth doesn't happen very often. That doesn't mean they don't happen.
This isn't the sort of thing that we want to address at the last minute.
An asteroid impact is a blockbuster kind of disaster.
Comets are still headed for Earth.
But is the threat of global destruction something we should actually fear? 66 million years ago, an asteroid the size of a mountain wiped out the dinosaurs and altered the global climate for years. So, could we suffer the same fate?
We don't want to be dinosaurs, but we are not as worried about it because we have been cataloging all the different sizes of asteroids and tracking them. At this point, we feel like we know 100% of all of the dinosaur killers, and they're not coming towards Earth.
Space agencies, including NASA, are confident they're tracking asteroids big enough to cause a major extinction event, and none of them are headed our way in the foreseeable future. But this doesn't mean we're safe.
Scientists are mostly worried about asteroids that are in a 100-meter kind of range.
They are difficult to see because they're small, because they are dark, and because they are really far away.
But even though they're hard to spot, these smaller asteroids can still do a lot of damage. Take the Chelyabinsk meteor, which lit up headlines in 2013.
A meteorite, or perhaps more than one, passed over southern Russia, eventually exploding in midair.
It detonated in the atmosphere, and that detonation was about 2 to 3 times as much as a nuclear bomb.
The shockwave can actually break windows, and the windows, they are going to harm people.
And that asteroid was only about 65 feet wide. Even relatively small asteroids could cause catastrophic damage. So, what are scientists doing to prevent the next major asteroid disaster?
We have a fantastic team of planetary defenders trying to find the near-Earth asteroids that perhaps pose an impact threat.
There are campaigns, not only in the US, but all around the world, trying to observe them and trying to classify them and trying to understand their orbits.
Of this 140-meter and larger size range, it's estimated there's 25,000 of those. To date, we're probably just a little over a third of the way in finding all of those asteroids. NASA has been doing this a long time, and it became more formalized in 2016 into the Planetary Defense Coordination Office.
Yes, planetary defense. By 2022, it plans to launch its very first spacecraft mission, called DART, short for Double Asteroid Redirection Test.
We want to know whether or not we will be able to redirect an asteroid.
Redirect. That means changing the path of an asteroid. To test if this technique could work, it needs to find not one, but 2 asteroids.
One is Didymos, the main asteroid, and then it has a small moon that orbits around it called Dimorphos. So DART's goal is to hit Dimorphos.
That's right, it's trying to move a moon.
To see whether or not we can change its orbit.
Even though the Didymos system is considered a potentially hazardous object, which means it comes actually pretty close to Earth. There's no way by us hitting the moon of the object that it changes the trajectory of the larger asteroid. We're testing out a technique called kinetic impactor. About 4 hours out before the impact, the spacecraft becomes fully autonomous. It will point itself towards the moon, make all the maneuvers necessary to slam itself into this really small object. So really, from 60,000 miles away, you basically started off and you guided yourself into a 160-meter object. It is very impressive and hard.
To determine whether the nudge was successful, scientists will look for changes in the moon's orbit. If the mission is a success, that means this might be an effective method to deflect an asteroid discovered to be on a collision course.
If we catch the asteroid early enough in its trajectory, we should be able to deviate it enough so that it just misses the Earth.
But what if there isn't enough time to deflect an asteroid?
The answer is not purely scientific. It also has to do with politics of how to deal with this. Even though this is called planetary defense, there are a few countries that really can do something, and those countries are those that have space mission capabilities.
And the countries who don't have such capabilities will have to depend on the goodwill of those who do.
Will those countries be able and willing to do something?
Right now, experts are conducting regional risk assessments and drawing up notification and evacuation plans.
At the Planetary Defense Conference, which is a gathering of researchers who work in planetary defense from around the world, we'll have these exercises where it's a hypothetical scenario where an asteroid is discovered that has some probability of impacting Earth, what their roles might be in addressing an impact threat. And ideally, you would find that object perhaps a couple of orbits before it ever poses an impact threat, so that you would have years or decades of notice to plan for it.